decomposition reaction, melting, evaporation, sublimation. Alright? Yun po yung examples ng endothermic process. Let's have life application. Yung melting of ice, yung tubig, bago siya uminit, kailangan niya mag-absorb ng, bago siya mag-melt, kailangan niya mag-absorb ng init, tama ba? Another thing is, yung pag-melt ng butter. Okay. Pag nag-melt tayo ng butter, kailangan ng init, tama? So that is endothermic process. Ganun lang kasimple yun. For exothermic process naman, heat is being released. Yun yung key term natin. So tandaan na itong mga summary po natin, ha? For number 1, example, forming chemical bonds naman, kabaliktaran. So kung kanina, nag-break tayo ng bond, bakit kailangan ng init sa pag-break ng bond? Kasi merong forces, intramolecular force or intermolecular forces in between molecules, tama? So para makipaghiwalay mo yung mga molecules, kailangan mo ng energy doon. Kaya endothermic process yon. Pag exothermic process naman, pag pinagbungbong mo yung dalawang molecules, or say, billiard ball, pag pinagbungbong mo yung dalawang billiard ball, di ba, it will create heat, tama? Ganon din sa mga particles natin. Pag nagko-combine tayo ng mga chemical compounds or even element, or atom, pag nagko-combine tayo ng atom, they would release heat. Kaya tinatawag siyang exothermic process kasi po, yung process na yun ay nagre-release ng heat. Okay, example nun ay forming chemical bonds or synthesis. Okay? Ito naman yung tatlong physical changes that involves exothermic process. We have freezing, condensation, and deposition. Okay, tandaan natin si freezing, ito ay liquid to solid, condensation ay gas to liquid, yan yung process ng phase change from gas to liquid, and then deposition ay gas to solid, kabaliktaran ng sublimation. Okay? Dito, sa tatlong ito, nag-absorb sila ng init. Dito sa tatlong ito, nagre-release sila ng init. Hence, they are called exothermic process. Okay? Can you still hear me? I wonder kung nawala ako.
Sir, narinig pa po.
Alright, all good. Sige, I'll just continue. For freezing, condensation, and deposition. Okay, life application. Kapag nag-form ng clouds sa atmosphere, okay, pag mataas ang humidity, tapos nag-condense yung water vapor sa hangin, di ba, it will form clouds. And then, kapag makulimlim ang panahon, mainit, maalinsangan ang panahon. Because, Chris Aquino, because ang condensation process ay exothermic process yan. So from gas to liquid, nagre-release siya ng init. Alright? Kaya kapag nag-form ang cloud sa atmosphere, mainit po ang panahon. Okay? Another example of exothermic process is combustion and burning. Tandaan po natin, sa combustion process, hindi po tayo makakapagsunog ng bagay kung walang oxygen. So before, doon sa theory, sinabi ng isang scientist na ang nagkukos daw ng pag-burn ng isang bagay ay phlogiston. Kung naalala niyo pa yung concept na yun, medyo luma na yun. But, ang kailangan na compound para makapagsunog tayo ay oxygen gas. Wherein doon sa outer space or in a vacuum, sa vacuum walang oxygen gas, hence, hindi po tayo makakapagsunog ng bagay doon. So the most essential or the essential compound for burning process or combustion process is oxygen gas. Okay? Pag tinakpan mo yung lampara, nilagay mo sa container, hindi na po siya aapoy because naubos na yung oxygen, na-consume na yung oxygen doon sa container after some time. Alright? So tandaan po natin, for the combustion process, kailangan po niya ng oxygen, and then the product is carbon dioxide and water vapor. Okay? Now, let's have another example, neutralization of acid and base. Ayan naman, neutralization of acid and base. Pag pinag-mix mo si acid and base, it will form salt and water. And there is no formal formation of bonds between the molecules. Okay, halimbawa, pag pinag-form natin o pinag-mix natin si hydrochloric acid and sodium hydroxide, okay, I hope na na-imagine nyo yung reaction. Pag pinag-mix mo yon, mag-form siya ng asin, NaCl or salt. Ang salt natin ay nanggaling doon sa yung anion niya and cation niya nanggaling sa acid and base. Okay, and then it will form water. Example siya ng exothermic process because ang acid and base ay nagdi-dissociate siya. There is no formal, walang formal na formation of bonds dito. Okay, tandaan natin, for the endothermic process, nawala ata ako. Ayan, for endothermic process, we have breaking of chemical bond. For exothermic process naman, we have um, forming of chemical bonds. Okay, sige lang, i-check lang natin ito. All right. So now let's have a test. Okay, concept check tayo. Since you know yung summary na, alam nyo na itong summary na to, kahit na magkoleho kayo at magtitake na ng board exam, ito yung mga basic or fundamental concepts na tatandaan po natin. Okay, nakasummarize na yan. Now let's have some example in here. We have the following equation, and then you will determine kung ano po yung process dito. Will it be endothermic or exothermic process? Tandaan po natin, kapag nag-combine tayo, synthesis yon, exothermic, we are forming chemical bonds. Pag nag-break tayo ng bond, hinati natin yung molecule. Okay, say decomposition process. Ang process nun ay endothermic. Now, look at the chemical equation above and then identify kung siya ay endothermic and exothermic process. Let's start with aluminum and oxygen, forming aluminum oxide. So ano kaya ang sagot dyan? Will it be endo or exo? So bago mo masagot yon, kailangan mo munang isipin kung nagfo-form ba tayo ng bonds dito sa number 1 or nagbe-break tayo ng bond. Okay, si aluminum at si oxygen pinag-combine and then it formed aluminum oxide. Okay, aluminum oxide po yan, hindi po yan di-aluminum trioxide kasi ionic compound yan, hindi yung covalent compound. Right? So ano po ang sagot natin dito for number 1? Let me see kung how many of you have the correct idea. Does it form or does it break bond? Okay, most of you answered exothermic. Let's see kung ano po ang tamang sagot dito. For number 1, since we are forming, pinag-combine natin si aluminum and oxygen, that means that is exothermic process. Very, very good. How about number 2? Nag-start tayo sa phosphorus pentachloride. Ayan, phosphorus pentachloride, it formed phosphorus and chlorine gas. Okay, so nag-start tayo sa compound, nahati siya into phosphorus and chlorine. Ano yun? Is it breaking or forming? Is it endo or exo? Let me see your answers. All right, very, very good. That was endothermic. Okay. Next, how about for number 4? Yung number 4, nag-start tayo sa dalawang atom, dalawang element, copper and chlorine. And then it formed copper chloride. Is it forming or breaking? Will it be endothermic or exothermic process? All right, so very, very good. That was exothermic. Kapag itong mga reaction na ito ginawa natin sa laboratory, mapapansin nyo sa container na umiinit yung container natin. All right, pag exothermic process. Now, how about for number 4? Ayan, so dalawang compound yan. Dalawang compound, carbon dioxide and water, and then it formed this compound, tapos oxygen gas. Parang ether ito. Ether or ester. Okay. Ano yan? Nag-break ba tayo ng bond dyan? Or nag-form tayo ng bond? Pansinin ninyo. Kung mapapansin nyo dito, nag-rearrange tayo ng mga atoms. So, na-rearrange si carbon, na-rearrange din si hydrogen, pati si oxygen. So, ibig sabihin nun, kung may rearrangement of atoms, nagkaroon ng pag-break ng bond. Tama? So, anong sagot? Exothermic. Okay, very, very good. How about this? Okay, how about this? Nag-start tayo sa compound, tapos nahati siya. Naging phosphorus and chlorine. Parang naulit lang siya doon, ano? phosphorus trichloride, tapos phosphorus, tapos chlorine gas ito. Okay, anong sagot natin? Very good. Ay, ang arte ng reaction. Very good. That was endothermic. Okay. I hope na lahat ay nakasunod. Okay, para ma-review po tayo na maayos. Okay, pag may mga ganong tanong, magsagot lang kayo. Ganun po talaga. Lalong-lalo na kapag magtitake kayo ng board exam, someday, ganito po yung setup ng review. Mabilisan lang. Mabilis din magsalita yung mga nagpapa-review. Okay, flash ko lang yung correct answers dito. I think medyo matatagalan tayo dahil mahaba-haba itong mga concepts natin. Sana matapos tayo before 12. So those are the correct answers. Ayan, hinide ko lang kanina. So you can take a screenshot of these para ma-review nyo later on. Pwede rin namin itong i-share sa inyo forward doon sa GC or G Classroom. Next, identify the following processes as endothermic or exothermic processes. So ito yung mga nasa PowerPoint ni Sir Kenny. Kinapi ko lang siya. Now, so we have the following. For number 1, again, identify if it's endothermic or exothermic process. Okay. For number 1, thermal decomposition. Ayun yung keyword natin, decomposition. Anong sagot doon? Mga ading. Ganito na lang, para minsanan. Sagutan nyo yung 1 to 5. Okay. Ilagay nyo yung complete answers nyo doon sa ating chat box and let's see kung ilan yung makukuha ninyo. Or minsanan na, 7, 8, 9, 8 items. Ayan. Subukan yung sagutan. I-hide ko lang yung concept. Meron tayong 8, and then send your answers. For number 1, thermal decomposition. Nag-decompose ka ng limestone, calcium carbonate, and then it formed calcium oxide and carbon dioxide. Number 2, explosion of firecracker triggered by a spark. And 3, combustion of hydrogen gas. Nag-burn ka. 4, nag-burn ulit. 5, neutralization ng acid and base, maybe strong acid and base. 6, combustion ng gasoline. Nag-burn ulit yan. Number 7, nag-dissolve lang tayo sa hot water. So, ano yung nangyari doon sa lead chloride? Or that is plumbus or plumbic? Plumbus, I think. Chloride. And number 8, heating causes sodium bicarbonate to decompose. Let's see kung ano po yung mga sagot po ninyo at kung ilan yung mga nakuha. Okay,
Yes,
minsan
sir.
na nasagutan. Yes, Sir Kenny?
Sir, sinabi ko lang po na tama, plumbus chloride siya.
Okay, sir.
Kasi plumbic is 4 ang oxidation number.
Alright, sir. Oo nga, sir. Yan, nire-remember ko lang kung ano yung mga sinasabi ko. Walang actual na review, oh my God. So kanina nung sinabi ko kanina, ay, matutuloy pala yung review ka ako. Yan, gumising ako ng mga alas 5 kanina. Tapos transfer ko yung mga files ni Sir Kenny. Actually, itong mga files na to, ito man nakikita yung concept sa harap, so sa screen ko ay nanggaling ito lahat sa PowerPoint ni Sir Kenny. So, dinagdagan lang natin, sinamarize natin. Alright? Pwede rin ninyong i-access yung video ni Sir Kenny sa inyong G Classroom. Okay? Now, ano-ano mga sagot natin? I-flash ko na po ang correct answers. Okay. Tignan muna natin kung marami na nagsagot. Send nyo lang po ang inyong kasagutan and then i-check niyo ang inyong mga kasagutan. Okay? Flash ko na po ang sagot. Then we will justify one by one kung ano po ang tamang sagot. For number 1, thermal decomposition. Again, pag nag-decompose tayo, we are breaking bonds, hence it is endo. Very good kung nakuha mo. For number 2, explosion, may apoy, exothermic yan. Basta may apoy, sige, exothermic. For number 3, combustion of hydrogen gas, exothermic ulit yan. Very good kung nakuha. Number 4, burning of coal, pareho lang din. For number 5, neutralization, exo, very good. Number 6, combustion of gasoline, halimbawa, methane, mga ganun, yung mga hydrocarbons natin sa gasoline. Okay, when we are burning gasoline, that is exothermic. Yung init ng pag-combust ng gasoline, yun yung nagbibigay ng driving force dun sa tricycle or sa sasakyan, okay? And then number 5, ayan, so plumbus chloride dissolves only in hot water. Na-dissolve lang siya. Anong nangyari sa plumbus chloride? That was nag-absorb siya ng heat, hence endothermic. And then number 8, heating causes sodium bicarbonate to decompose. Ayun na naman, decompose na naman. So endo. I hope na nasundan. You can review this summary dito sa gilid. Ayan. So lilitan ko lang yung screen ko para may screenshot nyo ng buo. Sa mga hindi naka-attend ngayon, pwede kayo mag-take ng screenshot, i-forward ninyo sa mga friends ninyo. Okay, so that's it for module number 8. Again, module number 8 pa lang yun, naka 30 minutes tayo. Alright, before we move on module number 9, do you have questions in mind? May katanungan? I'm giving you 1 minute to raise your hand or mag-notify sa chat box. Okay, if none, kung walang pong katanungan, you can send a heart reaction for us to confirm kung wala na pong question. Please send a heart reaction para ma-confirm namin kung wala ng question. Thank you. All right. I think most of you wala ng katanungan. I hope na malinaw na ang concepts for day number 8. Now, let's move on to day number 9. So habang papunta tayo sa day 16, parami yung competition dito. Okay, for day number 9 naman, we have this concept. I hope you have with you your calculator. Ito yung nasa PowerPoint ni Sir Kenny. And a sheet of paper. Tapos yung modules po ninyo. Okay, let's have module number 9, describing the heat flow and calorimetry. All right, we are done with endothermic and exothermic kanina. I'm sorry. Wait lang, may karugtong pa pala yung module number 8. I'm very sorry. Ayan. Sorry po. Nakaligtaan ko. Nagtataka ako bakit andun na ako. Okay, sige. Bumalik tayo sa module number 8. Thermochemistry. Okay, first law of thermodynamics. Nawala ako. Ayan. Alright, for thermochemistry naman, that is a branch of chemistry that study the heat flow, which accompanies a chemical reaction and or physical transformation. Sorry, I can show you yung my face. Hindi po magandang internet po namin, kaya naka-turn off po yung video ko. Heat refers to the energy transfer due to change or difference in temperature until equilibrium is reached. In thermodynamics, meron tayong tatlong laws. Okay. So maybe siguro, yung iba siguro very familiar na sa yung pangatlo. Actually, yung una. Yung zeroth law. O sinasabi sa zeroth law, zero. Zeroth law of thermodynamics na if system A is in equilibrium with system B, and system B is in equilibrium with system C, hence, system A is in equilibrium with system C. So parang sinasabi lang niya na kapag si letter A ay pareho ng temperature kay B, tapos si B ay pareho ng temperature kay C. Ibig sabihin doon, si letter A pareho lang ng temperature kay letter C. O ganun lang kadali si zeroth law. Pero si first law of thermodynamics, ang sinasabi lang niya sa atin ay yung law of conservation of energy na hindi nakikreate or nadidestroy ang energy. They were only transformed from one form to another. Kaya nga sa mga chemical processes natin, kapag nag-loss ng heat yung isang substance, yun din yung init na magiging ng another substance. Same thing in physics. Pag hinawakan mo ang isang object, say, I hope na merong metal na malapit sa iyo o kaya coin. Hawakan mo yung coin or metal. Okay. Pag hinawakan mo yung coin or metal, kung ano yung init na na-transfer doon sa metal, same thing lang siya ng init, ganun din yung value or amount of heat na na-absorb ng metal at yung nawala sa iyo. Pareho lang po yun. Q loss is equal to Q gain. Well, for the second law of thermodynamics, yung pangatlo, second law of thermodynamics is sinasabi niya yung law of entropy. Ang entropy, yun yung napapatungkol sa kung gaano ka-random yung particle sa substance. At nami-measure natin yun sa unit ng joules per Kelvin. Okay. So, kung halimbawa, yung principle ng second law, sinasabi niya na all things in the universe proceed to more random or more disordered. Okay? For example, the universe is constantly expanding according kay Edwin Hubble. That's Hubble's law of Hubble's law of galaxies. That was sinabi niya doon na every galaxy or each galaxies are moving away from each other. Hence, the universe is expanding. Hence, the universe is moving towards more random or disordered state. Yun yung tinatawag natin na entropy. Another thing is, pag nabasag yung baso, di ba, hindi natin siya mababalik sa original na state niya. So, ganoon din, may mga theories din about the universe na hindi daw pabalik yung yung state ng universe. Parang pagulo ng pagulo or pa-more random siya. Now, may theory din naman na nagsasabi na ang ultimate fate ng universe ay pabalik siya from nag-expand, nagko-condense. Okay, hanapin nyo na lang sa internet kung ano yun. I forget na the exact theory for that. Okay, for the,
Sir,
ayan. Yes.
Sir, I think yung sinasabi niyo is the Big Crunch, which is part of the oscillation theory ng Big Bang tas Big Crunch.
Oo sir, yun pala. So yun yung mga theories pala ng ultimate fate of the universe, yung Big Crunch. Ano pa yun sir, yung iba? Wala, nalimutan ko na talaga.
Sige lang, sir, go lang.
Sa dami rin kasi ng concept ng science. Alright, so ayun. Thank you so much, Sir Kenny. Now, let's move on computation. Ito po yung formula natin for computing the internal energy. Internal energy is equal to Q plus work. Okay, ang work is force times distance. Okay, and the force should be in perpendicular with the displacement of the object. Ang work po dito na ginagamit ay mayroon siyang sign ng negative or positive. Later on, papag-usapan natin. Ayan, for the formula ng pag-compute ng internal energy or total energy is equal to Q plus W. Then, pwede rin gamitin itong variables na to. Delta U is equal to Q plus W. If Q is, kung ang system ay nag-absorb ng heat, Q is positive. Q refers to amount of heat energy, okay? And then kapag ang system ay nag-release ng heat, kapag nag-release po ng heat yung system, it is negative. Tandaan po natin na ang system, that is the part of the world that we want to study, okay? Or yung term naman na surrounding, that consists of everything else outside the system. Okay? Now, kapag nag-loss ng heat si system, yung heat na yun ay mapupunta sa surrounding, the same amount. Kaya meron tayong principle na Q loss is equal to Q gain. Kung ano yung na-loss ng substance, yun din yung magigain ng surrounding or ng other substance. Okay? Ito po ang ating formula. We have delta U is equal to Q plus W. Q is positive if heat is being absorbed and negative if heat is being released. And W naman, work is positive if work is done on the system. Tandaan po natin yung term. If it's done on the system, use positive na sign. Pag the work is done by the system, use a negative sign. Let's have some examples below. Ayan po yung mga examples po natin. For number 1, we are asked to compute the following. A gas releases, so ibig sabihin nun, nag-release siya ng heat, our Q is negative. It releases 35 joules of heat and 84 joules of work was done to compress it. Okay, pag to compress, done on the system. Okay, yung init ay napunta doon sa system, done on. Alright, yung tinatandaan ko. Okay, so ibig sabihin nun, positive yung work natin. So ang sign ng Q natin ay negative since nag-release. Ang sign ng work natin ay positive since work is done on the system. Okay, let us reconfirm kung ang sagot po natin dyan ay 49. Okay, papakita ko lang po. Ayan, so confirm po natin kung tama ang sagot. You can use also your calculator. I know that ibig sabihin po ng positive na internal energy, the process is endothermic. Alright, nasundan? If heat is being released, Q is negative. If it's being absorbed, Q is positive. If work is done on the system, it's positive. It's done by the system, it's negative. Okay? Let's have another example. For number 2, let us reconfirm kung pareho kayo ng sagot. For number 2, a gas absorbs. Nag-absorb siya ng init. Tumanggap siya ng init, nag-gain siya ng init. So positive yung Q. And for our work is done by the system, by expanding. So negative po ang work natin. So positive ang sign ni heat, yung Q, negative yung sign ng work natin. Can you show your answer on the chat box? Let us justify or reconfirm kung tama ang sagot na negative 24. Ano po ang sagot ninyo? Pindutin ang calculator. That's 48 plus negative 72. Ayan. And we have negative 24 joules. And the process is exothermic pag negative po ang value natin. Okay. Marami-rami pa to. Sana matapos natin before 12. Okay, first law of thermodynamics again, calculation ulit ng total energy. Pareho ba ang sagot po ninyo? Sa number 2 pala? Ayan, so very good. Pareho lang daw. That was negative 24. Now, sa number 3 and number 4, ang tinanong naman ay, what is the work done by this system? And for number 3, ang tinanong ay yung heat energy. So, i-manipulate mo lang yung formula. If we are asked to find work is equal to internal energy minus Q. If we are asked to find Q, the heat energy, Q is equal to internal energy minus work. Okay, let us reconfirm. For number 3, what is the work done by a system when it absorbs 47 joules of heat and gain 12 joules of energy? So you have here, for work, since ang work niya ay, for internal energy, since it absorbed or gained an amount of heat, we have, sana yan? 12 joules for internal energy. While for the heat energy, we have 47. So parehong positive yan. For internal energy, we have 12. For Q, we have 47. Then let us reconfirm kung tama po ang sagot. 12 minus 12 minus 47, that was negative 35 joules. Alright? Ibig sabihin po ng negative 35 joules na work, the work is done by a system or by the system. Okay? And for number 4 naman, ayan, so kung nakaprint yung question, guhit-guhitan lang. Pag nagtitake ka ng exam, admission test, or board exam, guhit-guhitan mo lang yung mga given. Pero kung since Google Form naman na tayo sa online, i-take note mo, kailangan kong kunin yung mga given. So we have here for number 4, how much heat is released by a system when 45 joules of work is done on it to decrease its energy to 23 joules, and we're asked to find the Q. The internal energy now is negative 23 since nag-decrease. Ang work naman ay positive since work is done on the system. So we have to compute negative 23 and negative 45. We have 8 and then 6. Negative 68 joules. Ibig sabihin nun, ng negative 68 joules na Q, heat is being released. Okay? So nasundan po yung process. Again, ipaliitan ko lang ang aking screen para kita ng buo yung mga solutions. Ayan, you can take a screenshot of this. Alright, that's how we find the internal energy. Ganun po tayo mag-compute ng internal energy. And take note doon sa principles ng 3 laws of thermodynamics. Okay, do you have a question for module number 8? Ito na talaga. Tapos na tayo sa module 8. May katanungan? If none, kindly confirm, send a heart reaction again. All right. Nandito yung mga anak ko din pala, sina Christian. Tama ba ako? Student ko sila sa... Ayan,
Sir.
yan. All right, so I think most of you ay si Christian. Tumawag din ata siya nung minsan. Okay. We appreciate that pag may tumatawag na magtatanong sa lesson. Okay. For number... module 9 na tayo. Ayan, natapos na tayo sa module 9. We consumed 44 minutes sa module 8. For module 9, describing the heat flow and calorimetry. Calorimetry na po tayo. Ayan, so may sinummarize po ulit akong mga terms po dito na kailangan po natin tandaan. At kapag mag-take kayo ng science courses, ito naman yung paulit-ulit na concept na aaralin nyo kapag mag-take kayo ng science courses sa college, whether you take BSE Bio, BSE Chem, or physical science, or medtech, or engineering, meron po kayong chemistry at hindi po magkala yung concepts na aaralin nyo sa college. Parehong-pareho lang po yan. Kahit bali-balik ka rin ang mundo, ganyan po yung mga concept natin. Okay, for the following, I hope na malinaw ito. Ito yung mga term na napagpapalit-palit po natin. Heat, internal energy, and temperature. Ang heat po ay energy in transfer or transit. Yun yung energy na ibabahagi from one system to another. Okay, substance to another. Energy in transit. Tandaan mo lang yun. Kapag kahit na tumanda ka, alam mo yan. Carry mong aralin yung mas complex na concept. For internal energy naman ay that refers to the total energy in a substance or system. That is the total KE and PE. For temperature, yun yung average kinetic energy of particles in a substance. Tandaan po natin ng kinetic energy, that is the energy in motion. Kapag gumalaw ang isang bagay, may kinetic energy yun. Alright? And lahat ng substances or lahat ng matter ay meron siyang kinetic energy. Okay? From solid, mas onte, liquid phase state, greater than solid, and then for gas, mas marami siyang kinetic energy. Since free silang mag-flow and more collisions. Again, that's the differences between heat, internal energy, and temperature. Tandaan po natin yung mga terms ha, wag po natin mapagpapalit-palit po yan. And then for calorimetry naman, that is the measurement of the flow of heat through a system and its surroundings. And ito, calorimeter, that is the device to measure the amount of heat flow. Pwede kang mag-device, gawa ka ng coffee cup calorimeter by using styro cup. Pwede kang gumawa ng styro cup. You need also stirrer, ito yung setup sa gilid, styrofoam cup, tapos thermometer. Halimbawa, you want to measure the specific capacity ng isang substance. Halimbawa, yung silver metal. Papainit mo yon, tapos ilalagay mo dyan, tapos i-measure yung temperature. And may specific na process yan. Matagal na tayo hindi nagpapalaboratory, kaya hindi na rin tanda rin. Pero yun yung process, okay? Papainit ka ng metal, lalagay mo sa loob, dapat hindi nakaka-skip yung init. Then, ang magme-measure ng temperature ay yung thermometer. Then, perform the calculation with a given na constant na specific capacity. And then, i-compute mo yung specific capacity na gusto mong i-compute na metal sample. Okay? That's how we perform or we carry the experiment. Okay? Now, I would like to clarify yung concept ng heat transfer. Ano pa ba? At specific heat. Sige, start tayo sa heat transfer muna. Sabi dun sa second law of thermodynamics na ang heat is transferred. Di ba ang second law of thermodynamics that refers to law of entropy? Other thing, under nun, ang principle nun, meron pa siyang sinasabi. We have the heat transfer is being transferred from hotter region to colder region. Never did from colder to hotter. Hindi po ganun ang process. Ang natural na process po ay hotter region to colder region. Kaya minsan, sinasabi nila na, anak, or sabi ng teacher, na kung pakisara ang pinto, lalabas yung aircon, di ba? Sasabihin nilang gano'n. Ayun, naglakad yung aircon, gano'n ba? Hindi po. So, ang tamang sabihin po doon ay, anong tamang sabihin doon? Anak, pakisara ang pinto dahil papasok yung init. Tama ba ako? Are you still there?
Yes, sir.
Alright. Okay, sige. Sasabihin mo, the heat, ang init ay papasok sa loob. Ganun po yung process po natin. Never did from colder area to hotter area. Okay. One example, I hope na meron na malapit na metal sa inyo. Magawak ka ng metal or coin. Subukan mo magawak ng coin or metal, any metal. How does it feel? Does it feel hot or cold? Okay, you can use your microphone. Hindi ko po nakikita yung chat box na. Does it feel hot or cold po? Pag humawak tayo ng metal.
Cold, sir.
Cold po.
Okay, usually it's cold. Why? Bakit kaya? Anyone? Or you can send your response doon sa ating chat box. Okay, bakit kaya it feels cold? Shining heart. Bakit po kaya it feels cold? Because, Krisakina na naman. Because po, kasi ang nangyayari, pag humahawak tayo sa isang bagay na malamig, ibig sabihin na nabawasan tayo ng init sa katawan. The heat is being transferred from our body to that object. Okay, since ang metal ay good conductor of heat, mabilis siyang mag-absorb ng init, nabawasan tayo ng init, and we feel cold doon sa naka-receive ng heat energy. Tama? Alright, and that's the natural na process. Another thing is, bakit nagme-melt yung ice natin pag hinawakan natin or lalagyan natin sa palm? Bakit? Ang sinasabi ng iba, kasi sir, yung lamig ng ice ay napunta doon sa kamay. Which is not. Okay, hindi po ganun ang process. Kasi ang init ng palm or kamay ay napunta doon sa ice, kaya siya nag-melt. Ayun po yung process. So hindi po ganun ang pagsasabi ng statement natin kasi hindi po ganun yung natural na process. The process of heat transfer is from hotter area to colder area. Same thing sa air-conditioned na room, ilalagay po yung air condition natin sa medyo may tuktok kasi po yung process ay pababa po yung malamig na hangin tapos yung mainit na hangin ay paakyat. Okay, yun po yung process. That's a convection process. Pag nilagay mo yung aircon, nagpa-install kayo ng aircon sa bahay tapos nilagay mo sa baba, o di yung paa lang yung airconan, tama. Kasi nga, the cold air sinks and the hot air rises. Okay, tandaan po yung principle na yun, ang heat transfer. Okay? Now, ano naman yung specific heat capacity? Si specific heat capacity, mga ading, that refers to heat needed to raise the temperature of 1 gram, 1 gram lang ng substance, by 1 degree Celsius. Okay, ano bang silbi ng specific heat capacity? Yan po ay intensive property, specific yan sa mga bawat substances. At isa sa mga may pinakamataas na specific heat capacity ay yung water. It has 4.184 joules. Ganun siya kalaki, ganun yung requirement niya. Ngayon, if we would compare kung alin dito yung mas mabilis na uminit, sand or water? Okay, let's see your answer. Alin doon yung mas mabilis na uminit? Send your answers on the chat box. Mabilisan natin para matapos tayo ng maaga. I wonder baka umabot pa tayo ng 12. Marami-rami to. Pero bibilisan ko na. Alin po doon yung mas mabilis na uminit? Sand or water? Alright, very good. That was sand. Okay, bakit po sand? May kinalapan po yan sa specific capacity because would be because it has low specific heat or high specific heat. Lower or higher? Lower. Okay, very good. Pag lower po ang specific heat ng isang substance, mabilis siyang uminit. Yung rate yung rate ang tinutukoy natin. Pag low yung requirement, halimbawa, pag sabog pa lang ng araw ng umaga, ayan, kung i-compare natin yung sample natin ng sand at water sample, mas mabilis na uminit si sand because mababa yung specific heat niya. Sabihin natin nasa 2 joules lang, mga ganon. But I'm not really sure kung ilan talaga yung value na. You can search that on Google. While for water, it requires 4.184 joules. Ganun siya kataas. So, medyo matagal siyang uminit kasi kailangan niya ng, say, for example, for every minute, gagamit siya ng 4.184 joule para uminit siya ng by 1 degree Celsius. Tama? Ayon ang reason. Okay? Mas mainit po, mas mabilis na uminit ang sand kumpara sa water. And ang implications nun sa buhay natin, pag malapit ka or naninirahan ka sa malapit sa dagat, meron tayong tinatawag na sea breeze. Sea breeze and land breeze. Okay, pag sea breeze, I think umaga yon. Okay, kasi yung init ay yung init ay paakyat sa sand, mula sa sand, tapos yung lamig ay papunta doon sa may papabaliktad. Tapos sea breeze and then land breeze. Ayun yung implications na. Naku, wala. I forgot na ulit. Okay, so that was the implication. Dahil doon sa difference ng specific heat ng sand and ng water, nagkakaroon ng convection process at nagkakaroon ng pag-iba ng direction ng hangin pag naninirahan ka sa malapit sa dito dagat. Pag gabi, yung direction ng hangin ay papunta sa dagat. That was land breeze. Nagmula sa land papunta sa dagat. Then, pag umaga, sea breeze, I think. Magmula sa dagat papunta sa land. Alright? Now, I hope na those terms are very clear na to you. How to compute for the heat energy absorbed or release. Paano tayo mag-compute ng heat energy absorbed or release? Pwede natin i-measure yun by using this formula. Tandaan lang po ito. Q is equal to mCat. Wherein, Q is the heat energy needed in the unit of joules. Ang unit po ng energy ay joules. M refers to mass. C refers to the specific capacity, joules per gram degree Celsius. Tandaan po yung term. Specific heat capacity is the amount of energy needed to raise the temperature of 1 gram of a substance by 1 degree Celsius. Ngayon, pag nag-college kayo, siguro mamimit yung term na heat capacity. Wala yung word na specific heat. I mean, specific. Ang nakalagay dyan ay heat capacity. Pag heat capacity naman, pareho lang yung concept, pero naiba lang yung term at yung unit. Heat capacity is the amount of energy needed to raise the temperature of a substance by 1 degree Celsius. Okay? Ang unit po nun, I think, is joule per degree Celsius lang, walang grams. Pag specific heat, may grams, I think. Then for T refers to temperature. Alright? Carry na? Carry na pong mag-solve? May AC kung ready na po. Can you send a heart reaction on our chat box kung ready na mag-compute? What questions do you have in mind before tayo mag-proceed sa computation? You can open your microphone. Ayan, sabi ko na rin ito kanina. Ganyan po yung setup natin. If we assume that no heat is lost to the surroundings, then the energy absorbed in the calorimeter must be equal to the energy released inside the calorimeter. Nabulor na ako. Q gained is equal to Q lost. Kung ano yung nawala sa isang substance, yun ang matatanggap ng other substance. Kung ano yung nawala sa isang system, yun ang mawawala, yun ang matatanggap ng surrounding. Okay? Malinaw po yun? Because, ano po ulit yun? Because of the law of conservation of energy. Energy is being conserved. Kaya meron tayong ganong principle. Okay? Ready na sa competition? What questions do you have in mind? Wala naman na. I think okay na. Nag-send na ng heart reaction si Christian Paul and John. Ako medyo mahaba ba to? Magpahinga tayo ng konti siguro. Mga 5 minutes yun mamaya. Okay. Let's have some example. Iisa lang naman yung formula na gagamitin natin mga ading. We have Q is equal to MCAT. Now, kung marunong kang mag-manipulate, kaya mo na yan. Kahit natanongin yung C, yung M, or delta T. Kahit di na ito i-memorize. But if you prefer to memorize this, okay lang din. Kasi magkakaiba tayo na learning style, kumbaga. Okay? So if we are asked to find specific heat capacity, C is equal to Q over mat. For M naman, Q over cat. For delta T, Q over MC. Okay, pero ito lang yung formula na gagamitin natin. Pag hinahanap yung mga yan, i-manipulate, mag-divide, mag-multiply. Okay? Now, let's have some examples of computation. I hope you have reviewed your calculator now. Number 1, how much heat is absorbed by liquid water that weighs 550 grams? As it is heated from 25 degrees Celsius to 25 degrees Celsius. Our final temperature in here is 95 and initial temperature is 25. Final itong 95, ito kasi from tapos to, yun yung keyword natin. Then initial temperature is 25, final is 95. What is our change in temperature? Ano yung pagbabago sa temperature? 95 minus 25 is 70. Okay? And our C in here, since water ang pinag-uusapan, dapat memorize na po natin yan. Kahit pa tumanda tayo, alam pa rin natin yan. 4.184 joules per gram degree Celsius. Yun yung constant for liquid water. Alright? Q now is equal to MCAT. Then plug in the values. We have 550 grams multiplied to 4.184 joules, then 70. Can you confirm kung tama po ang ating sagot dito sa baba? 160930 joules. Use our calculator since ang pinahanap na naman sa atin ay Q, dire-diretso lang yan, mag-multiply lang. Kahit na hindi mo na isulat siguro, carry mo yan. So you have here, 550. I hope na buhay pa tayo. 550 multiplied to 4.184. Ayan. Then multiply natin sa 70. Let's see your answers kung pareho po. Patingin ko ng mga sagot. Pareho ba ang na-compute nyo guys? Let us reconfirm. Ayan, so some of you, Luis, Kyle, and Jonaline answered 160,930. Okay? And that's the correct answer. Very, very good. How about for number 2? Can you still see my screen? Baka po nawala ako. Okay pa ba, Kyle? Ayan, gumamit kasi ako ng 4.184. Eh, yung sagot, 161,084. Pero kung tanggalin ko yung 4 sa dulo, ganyan din yan. Now, naririnig pa po ako?
Yes, sir.
Yes, sir.
Okay, sige. Buhay pa. Pwede kayong uminom ng tubig. Ayan, inom lang kayo ng tubig. Medyo mahaba-haba to, pero push natin para sa quiz and exam. Okay, for number 2 naman, how many grams of fluid can be heated from 20 degrees Celsius to 75 degrees Celsius using 12,500 joules? Okay, given ang Q, 12,500. Then change in temperature, 75 and 20. 75 minus 20 is 55. Our mass is unknown. Then given the specific heat capacity, 0.3. Then plug in the formula. M, Q is equal to M cut. So hanapin natin si M. So M now is Q over cut. Okay. Q over cut, that was Q is 1,200, sorry, 12,500. Then we have 0.13 joules in here and then 55. Then reconfirm po natin kung tama po ang sagot. Kindly send your answers on our chat box. Ang unang magsisend ay may 5 million. Charot. Andun pa kayo, buhay pa kayo, sigurado kayo ha. Pindot lang po kayo ng calculator. 1748.25. Pareho po ba? Alright, or very, very good. Thank you so much. How about for number 3? I hope na pareho po ang na-compute niyo. For number 3, what is the final temperature of 800 after 84,000 joules is absorbed by 10 kilograms of base salt at 25 degrees Celsius? Ilan po yan? So plug in po natin ang unknown ay final temperature. Anong formula natin dyan? Delta T is equal to QMC. So paano ginawa yon? Q is equal to M cut. Hanapin si delta T. So mag-divide lang ng MC, divide ng MC, then Q over MC siya. Okay? Ganun lang po. Now, plug in the values. 84,000 divided by 10,000 multiplied to 0.84. Sige. I'll show you. 84,000 divided by 10,000. Sagaan lang po natin itong session natin. I know na medyo mahaba ito. So you have here 10 ang change in temperature. Kung ang change in temperature ay 10, what is the final temperature? Kung ang initial temperature ay 25, kung initial temperature ay 25, and then ang change in temperature ay 10, so ano pang final temperature natin? Gulat na ako, may butiking ano. may dumaan ng butiki. I'm sorry. So we have 35. Ayan, so 35 po ang final temperature natin. Did you get the same answer? Can you react heart if you have the same answer? All right, very, very good. Okay, can everybody send a heart reaction to confirm if you're still there? O baka yung iba nag-join tapos nakahiga, natulog na, ayun, na-plug, di ba? Can everyone send a heart reaction if you're still there? Ah, okay, sige. Buhay pa nga sila. Kala ko nawala na sila Baka nagmerienda na, ganun, umalis. Or natulog na, di ba? Yung mga ganung session minsan Akala ng teacher nakikinig pa yung mga student. Yung mga hindi nag-send ng heart, sige kayo. Sasabihin ko sana. Yung hindi nag-send ng heart, sige mababaog, charot. Ayan, okay, ayan, dumami na. I think they're still alive. Okay, let's proceed sa computation. I hope you are still with me. Oops. Okay, nasa enthalpy na pala tayo. So, tapos na pala tayo sa ano. Ganun lang pala. Okay. Oops. Ayan, so i-decrease ko lang yung screen ko. Pwede po kayo mag-take ng screenshot ng photo. Okay, yan po yung mga sunod natin. It seems that parang ang dami-dami, pero basically, ang formula lang ginagamit natin is QM cut, pinagbali-baliktad lang siya. Okay? Kaya po, pag nalilito po kayo, wag po kayong malito kasi isa lang po ang formula dyan. QM cut lang, binabali-baliktad lang. Minsan, tinapanap si mass, minsan tinapanap si specific heat capacity, minsan si delta T. Okay? Alright, so that was for the computation ng heat absorbed or release. Sir Kenny, include pa ba natin, sir, yung Q loss, Q gain? Or carry na ito? Hanggang dito lang tayo sa module 9. Pwede rin naman po yun i-share.
Sir, yung doon calorimetry, yung part na yun na slide, ito na po yun.
Sorry sir, medyo mahina pa ata ang audio po ninyo, hindi ko po marinig. Sir?
Sorry, may problem talaga. Ko.
Ayan sir,
Yung,
ayan sir.
yung last parts ng slide, yung Hess law tapos yung enthalpy sa module 15 na po yun.
Okay sir, so hanggang dun lang po tayo sa calorimetry, hindi na po
Yes
natin isasama yung heat of solution, ganyan-ganyan. So di
Sa
na
kwan
yun,
na po
sige.
yun. Yes, module 15 na po.
Alright sir, sige sir. Para din makapag-focus tayo sa fundamental concepts. That will be okay. Oh no, ayan na talaga. Oh no, no, no. Nagkahang na po. Can you still see my screen? Malinaw pa po ba? Malinaw pa yan? Kita
Yes,
pa?
sir. Yes, po,
Alright,
sir.
all good?
Yes, sir.
Oops! Nag-appear na yung Microsoft po. I will not be showing na yung ibang part, okay? Pagdating na siguro ng college, mamimit nyo lang din siya. But we focus on the fundamental concepts. For the standard molar enthalpy, ito yung parang nagsosolve tayo ng mga polynomials. Yung magmumultiply ka ng integer and then add mo lahat ng change in enthalpy. Okay? Medyo mahaba ba yung process na yun? So parang nagsosolve ka ng algebra equation. Okay, for standard molar enthalpy of reaction, the enthalpy refers to amount of heat absorbed or released by a chemical reaction at constant atmospheric pressure. All right, heat of formation, change of standard enthalpy of reaction is calculated as product minus reactant. So ganun lang po tayo mag-solve for the change in enthalpy. Tandaan lang po natin kapag yung enthalpy ang usapan, that refers to heat energy or
Sir Mark,
heat. Yes, sir?
sa module 15 na po yan.
Okay, sir. Nandun ba, sir? Wala, di ko ata na isama.
Yes po, sir. Module 9 pa lang po tayo, sir, no? So, ang module 10, I think, is rates of reaction. Tapos sa 15 na po, or 16 na ata yung enthalpy. Kaya doon na lang po yan madidiscuss, sir.
Okay, sir. Sige, sir. Minsan na lang garod dun, sir.
Yes po, sir.
Kasi sa module 9, napakapyawan po ata ito, Tama po ba, sir?
Po. Yes po.
Okay, sige. Doon na lang pala. Alright, sir. Thank you so much po. Now, let's move on to day number 10 and 11. Okay, I'm giving you 1 minute siguro for break. Inom muna ng tubig. 1 minute or 2 minutes. Ayan. Bago tayo mag-proceed sa... Ano yun? Ba't may nagsisend? Alak, panto. Ano yan? Mag-break muna. Siguro inom muna ng tubig. Grab your snack. All right, I hope you did. Grabe 1 minute or 2 minutes ko na. Sige lang, pwedeng mag-relax, pwedeng humika, pwedeng mag-snacks, mag-merienda habang nakikinig. All right, let's have module number 10 and 11 na tayo. More to go. For day 10 and 11, it talks about factors affecting reaction rate. Okay, now before I present my screen yung presentation, can I ask you what can you remember about the factors affecting reaction rate? What are those? Ano po yung mga factor? Pwedeng Tagalog. Ano po ulit yung mga factor that affect the reaction rate? Okay. Minsan meron ako nakitang test item na Tagalog yung tanong. Chemistry yun ha. Tapos Tagalog yung tanong. Pwede rin mag-Tagalog. temperature, then surface area, ano pa? All right, according kay Angela, that was concentration. For Luis, a catalyst also can alter the rate of reaction. Very good. Ano pa? Ano pa yung naalala niyo? Or mga processes. Ano yung processes para mapa-alter po natin yung rate of reaction? O yan, ito man po nasa sakyan. It's written 40. Diyos ko. Sige, bilisan na natin. So, that was, or those are the factors affecting reaction rate. So we have here concentration. Number one is concentration. Increase in concentration will result to faster rate of reaction. See, for example, increasing the concentration of hydrochloric acid from 2.5 molar, ayan, usually yung mga substance natin sa laboratory ay naka-report siya into molar concentration, capital M. Pag small letter, molal. Okay, molal siya. Then to 4.0 molar hydrochloric acid would result to faster rate of reaction with an active metal sample. Or say for example, kung gusto mong mapabilis yung paglinis ng ano natin, ng kubeta, pili ka ng ano ng panlinis ng kubeta na mas mataas yung concentration niya, mas effective. Ganun din, pag naghuhugas tayo, di ba, we are using yung dishwashing liquid and may mga concentrated na product at may mga diluted. Pag sinabi natin concentrated, mas maraming solute doon na dissolve doon sa solvent. Pag ano naman, undersaturated or diluted siya, marami siyang halong tubig. So mas effective gamitin yung concentrated. Okay, one is concentration. Good. Number two, particle size or surface area. By cutting or grinding or pounding the solid reactants or substances would result to faster rates. So for example, mas mabilis tayong mag-dissolve ng sugar na powdered kaysa sa sugar cubes because of the surface area. Pag mas maliliit yung particle size, greater surface area ang na-expose. Greater or more collisions would result to faster rate of reaction. All right? How about for number three? We have the temperature. Ayan, nakasummarize na siya. Increase in T or temperature would mean increase in the rate of reaction. Why? Ano pong reason? Because when you are raising or increasing the temperature, you are increasing the average kinetic energy of particles in substance. So, ibig sabihin nun, pag tinaasan mo si kinetic energy, mas energetic yung mga particles natin, tama? Mas energetic, then faster rate of reaction. Yun yung reason, alright? For number four, the presence of catalyst. A catalyst is a substance, ang arte, no? Substance that speeds up reactions without being consumed. Okay, yun naman yung function ng catalyst. So those are the four factors affecting reaction rate. Now let's have the following concept check. Okay, tignan po natin. Kita ba, guys? Kita po ba? Ayan, ganyan ko na lang para kita ko rin yung pinapresent ko. Now, you can use the chat box in sending your answers. Let's have the following. For number one, indicate whether each of the following would increase or decrease the rate of reaction. Number one. Okay, number one, the answer is increase. Okay, bakit siya increase? Because we are adding more heat, we are increasing the temperature, we are increasing the kinetic energy of the particles in a substance, more collision. All right? How about for number two? Number two na tayo, removing heat. Mabilis lang sa pagpindot. All right, very, very good. For number two, decrease in rate of reaction because we are removing or decreasing the kinetic energy of particles in a substance. Number three, adding a catalyst, like say, for example, a yeast or an enzyme. It would increase the reaction. All right, all good. How about for number four, diluting a solution? Diluting means you're adding more water. Di ba yung isang, ano ba yun yung joy? Isang patak ng joy para sa isang linggong hugasin, sabi nila. So you're diluting the joy. Diluting means you're decreasing the concentration, hence decreasing the rate of reaction. And number five, removing an enzyme. nagtanggal ka ng enzyme. Siya yung magpapa-speed up ng reaction natin. Very good, that was decrease. How about number 6? Lowering the temperature. Mabilis ang pagpindot lang po, ano? Alright, very, very good. That was decrease. Wala pa akong nakikita ang nagkamali. For number 7, increasing the temperature. Si Kyle sinenda lahat. Increasing 7, ayan, very good. How about number 8, decreasing the surface area? O sige, number 8, numberan nyo ito. Number 8, decreasing the surface area. Ano pong sagot dyan? For number 8, the answer is, when you are decreasing the surface area, it would, I think, oh wait. We're decreasing. More surface area exposed, more. It should be decreased, I think, for number 8. Why? Because diba pag we increase the surface area, more area was exposed. We are, mas faster ang rate of reaction. Pag na-decrease natin yung surface area, lesser area ang exposed. Mas mababa yung rate of reaction natin. Okay. Iba kasi yung surface area sa particle size, ha? Kapag malaki yung particle size, tama? Pag malaki yung particle size natin, maliit yung surface area. Pag maliit yung particle size natin, maliliit. Malaki yung surface area. Exposed. The area exposed. So for number 8, it should be decreased, I think. While for number 9, ano po yung number 9? Increasing the concentration of a solution, it would increase the reaction. And for number 10, breaking a reactant down into smaller pieces. Ayan, yung particle size ng tinutukoy dito. If we are grinding, pounding, mga ganyan, nililiitan natin yung particles, di mas mabilis tuloy yung reaction. Very, very good. Those are all correct answers for number 10. Dun sa number 8 lang tayo medyo nagkarituhan. Ano? All right. Increase 9999. All right, that's for, I think, number, tapos na ba tayo for number 10? Ayan, 10 and 11. That would summarize module number 10 and 11. What questions do you have in mind before we move sa next module? Module. Can you send a heart reaction kung wala namang katanungan? All right. Now we can move on to module number 12 and 13. I think module 12 and 13. Ayan. Inom lang po ng tubig muna. I-lubricate ang bunganga. Lalamu. Ready na? Ready na po ba? I hope you did. I hope na uminom kayo ng tubig. Okay. Next, punta tayo sa day number 12 and day number 13. It talks about catalyst naman. So, papag-usapan naman natin yung catalyst. Now, in here, I think may mga common misconceptions tayo dito. And we need to address that. For a catalyst, for number 1, ito yung mga key concepts niya. One is, you can take a screenshot of this. 1, a catalyst is a substance that can be added to a reaction to increase the reaction rate without getting consumed in the process. Tandaan, dinadagdag siya para i-speed up or i-alter yung rate of reaction and without being consumed during the process. For number 2, ang function ng catalyst ay to speed up a reaction by reducing the activation energy. Ayan. Nire-reduce niya yung activation energy. Nasaan yung drawing dito? Nawala ka. Ayan, dapat andyan siya. Nawala sa eksena. For number 2, is speeding up the reaction by reducing the activation energy. Etong dito sa diagram natin, this is, I think, a favorable condition wherein mas mataas yung energy sa reactant kumpara sa product. So, favorable condition yan in the formation of the product. Okay? Etong curve na nasa taas, magmula sa reactant, paakyat ng curve, ay tinatawag natin na activation energy. Ginagawa ni catalyst, pag dinagdag sa chemical reaction, ilo-lower niya yan para bumilis yung chemical reaction. Kasi kung yung reaction ay maggaganyan siya, mag-slower paakyat, mag-slow down, pababa, mag-speed up. Alright? Now, by lowering the activation energy, lesser ang potential energy, mas mabilis po ang reaction po natin. Yung nasa baba naman, yung gap in between reactant and product, that is the free energy. If the free energy is lesser than 0, that is favorable. If the free energy is greater than 0, that is less favorable since it is not spontaneous, and we need a driving force or initiation para mangyari yung chemical reaction. Now, for number 2, again, tandaan po itong key concepts niya, wag po tayong mawawala dito. It only speeds up the reaction by reducing the activation energy. Okay? It doesn't alter also. Hindi niya binabago yung energy change ng Gibbs free energy. Si Gibbs free energy, yan yung free energy that initiates a reaction. And the reaction could be spontaneous kapag negative ito. Kapag positive ang value ni delta G, yung change niya. Yung change we are referring to the change. Pag positive yung change, non-spontaneous. Pag negative, it is spontaneous. So later on, papag-usapan natin yan in details. For number 3, enzymes are proteins that act as a catalyst in biological reactions. So example ng catalyst ay enzyme. Some of our catalysts ay mga inorganic available sa laboratory. Common types of catalysts include enzymes, acid-base catalysts, and heterogeneous or surface catalysts. In our body, we have several examples of catalysts wherein their function is to speed up the reaction. For example, for our enzyme, we have catalase. Ang catalase ay present siya, I think, sa plants like potato and also present in animal liver. Lipase, pwede rin. And we also have DNA polymerase. Those are examples of enzyme or catalyst. Now, for naulit yung numbering ko po. Number 4. For number 4, pasensya na. Hindi ko napansin. Kanina nagmamadali ako na, 9:30 na ako. For number 4, a small quantity of the catalyst is generally sufficient to catalyze almost unlimited reactions. For example, in the decomposition of hydrogen peroxide, 1 gram of colloidal platinum can catalyze liters of hydrogen peroxide. But si hydrogen peroxide, yung agua oxinada, tama yung ginagamit sa ng mga babae, yung pag ililis ng kuko. Si hydrogen peroxide or agua oxinada ay natural yan na nagde-decompose. Pag binuksan mo yung container niya after some time, magde-decompose yan into hydrogen, I think, and oxygen gas. Okay. Now, to speed up the reaction, we could use this catalyst, platinum, yan, without being consumed. And only a small amount ang kakailanganin natin doon would suffice. Now, for number 5, the catalyst cannot initiate the reaction. Maybe siguro, ito yung common misconception natin. It doesn't initiate the reaction. Ang function lang ni catalyst ay to lower the activation energy and to speed up the rate of reaction. So, ang kinalaman lang ni catalyst ay doon sa kung gaano kabilis yung reaction. Hindi po siya nag-i-initiate ng reaction. Kasi I think ang nag-i-initiate ng reaction is the delta G. If delta G is negative, it's spontaneous. If delta G is positive, it's non-spontaneous and it needs a driving force or initiation. Okay? Later on, papag-aralan natin yung examples na spontaneous and non-spontaneous. Now, the key principle in here below, the higher the activation energy, the slower the chemical reaction will be. Okay, and by using a catalyst, we can lower the activation energy and it speeds up the reaction. We have two types of reaction in here. We're involve ang catalyst. If reactant has higher energy compared to product, that is exergonic reaction. Kahit na wala kang gawin dyan, it would happen, the reaction will happen. While for endergonic reaction, the energy on the reactant side is lower than the product side. Wherein, eto, yung delta G natin ay positive, ang value niya, it is non-spontaneous. Hence, it requires initiation. Okay, may mga examples tayo na ng spontaneous processes. Halimbawa, yung process ng, ang tawag dito, pagpapalamig ng loob ng refrigerator, kung paano siya lumalamig. Sa refrigerator, meron siyang condenser, meron siyang evaporator. So, dadaan yung liquid, yung freon sa loob at labas ng ref. Pag papunta siya ng loob, mag-evaporate siya since sobrang init sa loob ng ref. Yung init na yon ay na-absorb, papunta siya, dadaan sa likod yung liquid na yan, then i-release niya sa labas through condensation. So that's, I think, an example of non-spontaneous process, wherein that is against doon sa process ng heat transfer. Wherein sa heat transfer, the heat is always being transferred from hotter region to colder region. Okay? Now, let's have an exercise again. Sagutan po natin ito. Kita po ba? You can use the chat box again. Number
Yes,
one.
sir.
All right, all good for number one. When the increase or when there is an increase in temperature, paki-correct, the rate of reaction increases because A, more number of collisions, B, more number of energetic electrons, C, less number of energetic electrons. Natuyo na ang lalamunan. For letter D, decrease in mean free path. What do you think is the correct answer there? Very good. The answer is letter A. Why? When you are increasing the temperature, you are increasing the average kinetic energy particles in a substance. Hence, mas greater ang chance for collisions, more collisions. All right, very good. How about for number two? Which is not true about a catalyst? A, B, C, or D? For A, it changes the rate. B, it is more effective in powder form. C, it starts the reaction. And D, its mass and composition do not change during the reaction. The correct answer there is letter C. It doesn't start the reaction or it doesn't initiate the reaction. It only speeds up. Okay, next number three. What does a catalyst do to a reaction? A, it slows down the reaction. B, nothing changes. C, it speeds up the reaction. All right, all good. I think most of you got the correct answer. How about for number four? What do you call the energy that is required to start a reaction? Ayan. A, alternative energy. B, activation energy. C, atmospheric energy. All right, all good, very good. The answer there is activation energy. How about for number five? Catalyst may be in the state of A, S and L only, B, liquid and gases only, C, solid and gases, and D, solid gases and liquid. Pagbaliktad. All right, very, very good. Gagaling. For number five, the correct answer is letter D. Lahat yan. Pwede yan. And then, for number six, how does a catalyst work in speeding up a reaction? A, by lowering the activation energy or reaction. Ano? Activation energy of reaction yan. And D, by making them more available. And C, by giving them more energy. What's the answer for number six? May nagsagot ng D. Wala pong D doon. Charlie. Okay, for number six, the answer there is letter A. All right, very, very good. How about number seven? What is the name given to a catalyst? All right, so the answer there is letter C. But may haha, Robin. So, yun ang tandaan po natin. Ayan, pag alam na natin yung alam natin po yung concept na yan. O di, kahit pagbalik-balik rin pa yung mga test items, yan, yung 7 na yan, yung 7 na questions na yan, that is very fundamental concept. Kailangan matandaan po natin yan. And even yung mga summary po dito, pati yung diagram, kahit hindi mo siguro i-memorize yung itong mga concepts dito, basta alam mong explain tong diagram, Keredals na yan. Okay? What questions do you have in mind before we move on the next part? You can just type your question. And if none, you can send a heart reaction to confirm kung wala na po, and we can proceed to the next part. Hindi sumakit likod ko. Back pain in your area. Module 15 na yan, hindi ko nagawa. Pero may PowerPoint si Sir Kenny dito. Gagamitin natin yung PowerPoint ni Sir Kenny. Module 15 and then 16. Ayan. Later, kung kayang buksan yung whiteboard, sana makipag-cooperate siya. For module 15 and 16, ayan, papag-usapan na po natin yung Gibbs free energy, entropy, enthalpy. At paano nakaka-apekto si entropy, enthalpy sa Gibbs free energy or energy, delta G. Ayun po yung papag-usapan natin this time. Second law. Okay, mamaya ipupuntahan ko yan. Saan na ba yun? Okay, buksan po natin ang ating module. Deto tuloy. Nabulol deto. Dito sa part na to ng inyong module ay medyo magbubuno tayo. Magko-compute po tayo ng mga values for delta S, and then delta H, and then Gibbs free energy. Just wait for my screen. Ayan, I hope na makapag-cooperate itong whiteboard ko. And if not, I'll just open the PowerPoint. Okay, siguro while waiting, you can take a break, grab a snack, drink your water, B. Ang tagal. Tagal mag-open ng whiteboard. Pasensya na, naririnig niyo ba yung nanay ko? Hello? Are you still there? I wonder, baka po nawala ako.
Yes, sir.
All right, all good. Sige, let's proceed to day number 15. On day 15, it talks about, can you see my screen now? Kita po ang ating screen?
Yes, sir.
Yes po.
All right, all good. Thank you, thank you. Mm-hmm. Explaining entropy and the second law of thermodynamics. Again, for the second law of thermodynamics, it's just the law of entropy, or it tells us kung paano po yung heat transfer. Spontaneous, non-spontaneous, second law. Yeah, second law of thermodynamics. Oops, this is first law. Ayan, for the first law of thermodynamics, it states that energy cannot be created nor destroyed. That was the law of conservation of energy, restatement of law of conservation of energy. For second law of thermodynamics, it talks about the quality of energy. States that energy is transferred. Oh, first law yan, first law. Second law also states that there's a natural tendency or any isolated system to degenerate into a more disordered state. So tandaan lang natin yung second law. Okay, ano po ang entropy? Yan po, nabanggit na rin natin kanina. Entropy is the measure for randomness, degree of randomness. And the units or the unit is joules per mole Kelvin or joules per Kelvin mole. Okay? And take note of the following concepts below. Solids are very ordered and have low entropy compared to liquids and gases, and even aqueous solutions, I think. Since in liquid and gases, particles can move freely, then mas mataas ang degree of randomness nila. Mas mataas yung entropy nila. Ordered state and disordered state. And that's a comparison. Okay, we have the following rule, how to determine if entropy is positive. Entropy is positive when kapag ang solid ay nag-form into liquid or gaseous product. Halimbawa, we start with, ano bang solution na naging gas? Wala akong maisip na chemical reaction. Say our reactants there are solid form, tapos nag-form siya into gas. That was, the entropy is positive. Say, sublimation. Okay, sublimation is, hindi naman siya chemical reaction, but a physical change. But the phase change from solid to liquid, like yung sublimation of naphthalene ball or yung mothball. Okay, another thing is, liquid reactants form gases. Pwede rin yun. Another thing is, many smaller particles that coalesce into larger particles, typically indicated by fewer product or product moles than reactant moles. Or kapag mas marami pong moles on the product side, mas maraming substances, we could tell that the entropy change, ang entropy change ay positive. And negative naman ang entropy natin kapag, pagtanda na, kapag positive po ang entropy natin, there is an increase in entropy. Pag negative po ang entropy natin, there is a decrease in entropy. Okay. Meaning, pag positive ang value, mas gumulo. Okay. Pag negative, mas pumunta siya or nag-proceed siya sa more ordered state. Okay? Entropy is negative kapag ang gas ay nag-form into liquid or solid. Since yung gas, it has free molecules or freely moving particles. Then nag-form siya into liquid or solid, which is more ordered, hence the entropy is negative. Ano ba yan? And large molecules dissociate into smaller ones. Tapos there are more moles of gas in the products than there are in the reactants. Oops. Okay, here are the examples. Liquid water freezes from liquid to solid yon. So the change in entropy, tandaan po ha, we are referring to the change in entropy. We're not referring to the entropy itself. So the change in entropy is negative. For number 2, naphthalene balls sublime. So positive po yun because nag-increase po yung disordered state ng particles. And for number 3, positive din siya because there are more products than reactants. There are more moles of products in the product side than on the reactant side. Okay? Pag dumami or mas marami yung particles or substances on the product side, we could infer, okay, we cannot say absolutely na talagang positive siya. Kasi there is other way pa to determine the entropy change, which is yung magko-compute na tayo ng standard value. Okay, this is just a prediction or inference kung siya ba ay positive or negative by following these rules. Okay, for number 3, we have more substances on the product side than on the reactant side. Hence, we could infer or conclude that it's positive. Pero maaring negative siya pag nag-compute tayo ng standard value. Okay, for number 4, in here, since from liquid tapos naging gas and gas yung product natin, we could infer that it's positive. Nagkaroon ng mas maraming entropy or degree of randomness. For number 5, in here, since mas marami sa reactant side kumpara doon sa product side, okay, we could infer that the entropy change is negative. Tama nga naman, kung magko-compute tayo ng standard value niyan, mas marami sa reactant side, mas marami tayong isusubtract na value. Hence, our predicted value is negative. Okay? That's how we predict the entropy change, kung increase ba siya or decrease, positive ba siya or negative. Tandaan, kapag positive, increase in entropy. Pero, decrease in order. Kung kayang i-process yung information na yon. Pero kung gusto mo hanggang doon lang, kapag positive, increase in entropy, o parang hindi naman rito. Pag negative, decrease in entropy. Alam nyo na yan. Kasi kapag entropy, that refers to the degree of disordered state or randomness. Now, those are the rules in predicting whether a chemical reaction or process would have an increase or decrease in entropy, or a positive or negative value for entropy change. Okay? This is how we find the value for the entropy change. We have delta S is equal to the summation of the standard state for the entropy of products, and then standard state naman ng reactants. Subtract lang natin yung value. And then, yun na po. And we can also find the table on your activity sheet. Paki-detach po yan para pag nag-solve tayo, mabilis po tayo mag-compute. And we will only give you items, I think, tama Sir Kenny, no? Items na dito lang mahanap. Kasi may mga substances talaga na wala po dun sa table. And we make sure na yun lang po yung bibigay namin on the quiz and exam. Okay? Now, there are other tables na mas marami pang laman nito. Since marami yun, hindi kaya niya attach lahat yun sa activity sheet po ninyo. But they are available on the internet. Okay? Paki-detach po yan para mabilis po yung competition. I'll be sharing my whiteboard and punta na tayo sa competition ng entropy.
Sir, bali ang gagawin na lang sa quiz tapos sa exam, ang gagawin na lang per question naka-indicate na kung ano yung entropy values or enthalpy values ng mga substances. So hindi na sila
tama
maghahanap.
nga. Oo nga, sir. Yay. Thank you, sir. Alright,
Sir,
so last
ang pag-usapan na lang natin kung ibabalance natin o hindi yung chemical equation. Ibalance na ba natin o hindi pa?
I think siguro i-balance na lang po natin kasi baka may mga hindi pa makasunod sa balancing of equation.
Okay, sir. Sige, pagbigyan natin. Pero sa susunod na exam, sa May, hindi na natin ibabalance kung sakali.
Yes, sir.
Parang
Yes, sir.
pagbigyan lang nila natin ngayon. Sige po.
Alright, sir. Thank you so much, sir. Okay. Now, let's move on sa competition ng entropy. I'll start sharing my screen. Oops, kita po. Kita naman mga ading.
Yes, sir.
Mainit na ang panahon. Okay, zoom in ko lang, ano. You can use your table para hindi ako, tingin ng tingin doon sa table ko, ha. Mag-refer po kayo sa table po ninyo. Buksan po, buklatin ang modules. I'm sorry. Tanghali na. Nag-aaway. I'm sorry po kung may... Hindi po talaga maiwasan yung pag-online. Mga unnecessary background noises. Okay. Oops. Sorry for that. Wait lang po. Sorry. Sorry for that. Narinig niyo po ba? Sir Kenny. Hello, can you still hear me? Hindi po. Okay. Thank God, hindi niyo narinig. Okay. Pasensya po kung halimbawa man ay narinig niyo yung nangyari. Sorry for that. Pasensya po. Gutom lang yung tatay ko. Ganun po yung paggutom. Ano? Na-inform ko naman na may online kami, may online class ka. Ganun po talaga. We're very sorry for that. Nahiya, kung yung nahiya. Now, let's proceed. I hope we're okay. We're still okay. Sir Kenny, naririnig pa po ako?
Yes, sir. Ako ata yung hindi naririnig.
Yes, naririnig po, sir.
Yes,
All right,
po.
let us have a sample problem. I think it's part of your activity na mahanap niyo po ito sa inyong activity. For number 1, is the entropy, letter A, is the entropy change for the electrolytic decomposition of water positive or negative? Yun yung tanong. We are given the equation, water in liquid form and hydrogen gas. Tapos, water in liquid form, it formed into hydrogen and oxygen gas. This is the process of electrolysis, wherein yung papadaanan mo ng kuryente yung tubig para mag-form into hydrogen gas and oxygen gas. Now, how do we compute the entropy change in here? Take note of the balance equation. Sa balance equation, meron tayong mga numbers sa gilid ng mga substances. Okay, pag walang nakalagay, it means 1. Right? Now, this coefficient refers to the number of moles for the substance. Halimbawa, on this equation, balance equation, dun sa example, hindi po na-balance. Ito po yung balance equation. We have 2 moles for water, 2 moles for hydrogen, hydrogen, and 1 mole for oxygen. Ayan. Now, how do we compute for this change in entropy? Delta S is equal to yung sum ng product, isusubtract lang natin sa sum ng reactant. Okay. Now, let's identify first. Ang first step ay identify muna natin kung ano yung mga value ng bawat substances. For liquid water, ang value niya ay 69.9. Pakihanap na lang po sa inyong activity sheet para siguro mabilis akong mag-discuss. Ano? Okay? Nahanap po ba? Nakita niyo ba mga ading? Okay. Nahanap niyo po ba mga ading? For water, liquid water is 69.9. Okay? Alright. Siguro pag ganun, itatanong ko, i-reconfirm ko, you just send a heart reaction. Okay, send lang kayo ng heart reaction pag nahanap po yung mga values. For water, it's 69.9. Tandaan po, lipid po yan. How about for H2? 130.6. Nahanap ba? Pareho pong nakita. H2, hanapin. That was alphabetically arranged, I think. Can you still see my screen? Kita pa, Kyle?
Mga anak, sagot please.
Alright, tulog na ata sila. Okay, can everyone send can everyone send a heart reaction again to confirm kung andito pa lahat? Ayan, buhay pa sina Prince. Luis. Okay? I think buhay na buhay pa sila. Kung nagugutom kayo, maaaring you can grab, snack, inom ng tubig. Okay, ilan na lang to? Saglit na lang ito, matatapos na tayo. Alright, I think buhay na buhay pa sila. Okay, now, sige, I'll just show the solution na lang and then yung part ng paghahanap ng values, that's your part na lang. Hanapin nyo na lang po sa table po ninyo. Kasi kung ako maghahanap pa itong isa-isa, medyo pantagal tayo. So for water, 69.9. For H2, 130.6. Makikita ito sa table. And then for oxygen, we have 205. Now, i-plug in natin, delta S is equal to the product minus reactant. Delta S now is 2. Multiply po natin sa 2 sa coefficient niya. For H2, we have 2 moles. For water, we have 2 moles also. So, ito yung product side, ito yung reactant side. I-subtract natin yung value dito doon sa reactant. So, we have here 2 times 130.6 plus 205 sa oxygen. Subtract 2 times 69.9. Plug in. Gamitin ang calculator. Let us reconfirm kung tama ang sagot. You have here 2 times 130.6 plus 205. Ayan po. I hope you are doing this now. Ilabas po ang calculator. 69.9. I-reconfirm po natin kung anong sagot. Then, click equal sign. Pag ganyan pong lumabas, if you have the same calculator, click SD. And you will get 326.4 joules per Kelvin mole. And I would like to correct this. Sa activity sheet kasi, nakalagay, ganyan ang unit. But I think ang unit for delta S should be joules per Kelvin lang. Pag change in entropy, given the moles.
Yes po sir,
I think.
tama.
Tama, sir?
Yes po, kasi yung mole kasi doon sa unit ng entropy, which is joules over mole Kelvin, tapos imumultiply siya sa mole, so makakancel po yung mole, ang malileft out lang ay joules over Kelvin lang po.
Yes, sir. Ayun. Nadali din ako doon. So, ito ay nagawan ko na rin ng video and I would like to correct that kasi nakita ko dun sa activity sheet, ang ginamit na unit ay nag-start siya with joule per Kelvin mole. In example, problem doon ng carbon monoxide. So, yun yung sinundan ko. And I thought okay siya. And then, nung napunta ako sa day 16, I realized that the unit for the delta S should be joules per Kelvin lang. But, minor problem lang yan. Kaya yan, may tatawid yan. Joules per Kelvin po ang unit for delta S. Paki-correct na lang. Alright? Now, for number 2, you have here, we are given the equation, carbon dioxide plus water yields to glucose and 6 moles of oxygen. This is the equation for photosynthesis. Pag tinanong kayo sa exam, admission test man yan, or yes, Kyle, yun lang ang unit, joules per Kelvin. Wala siyang mole. Okay, paki-correct po yun ha. Alright? Pati ako nadali ako dun sa module eh. Hindi ko na, buti na lang dun sa module 16 na i-correct siya. Now for letter B, we are given the equation, yan yung madalas na tinatanong din sa admission test or board exam. Pag tinanong kayo, what is the balance equation for photosynthesis? 6 pa nyo. 6 for carbon dioxide, 6 moles for water, 1 for glucose, and 6 moles for oxygen. O yan. Pag tinanong yan sa pag lumabas yan, di alam nyo na. Alright? Now, identify the values. First step, identify the values ng entropy for each substances. Sorry. Ayan po. So, 6 times 213.6 yung carbon dioxide. Hanapin lang po. For water, in liquid to, gamitin natin yung liquid, 69.9. Alright? times 6 kasi 6 po yung coefficient. For glucose, since, okay, wala po sa table yan, 212. Ang glucose ay wala siyang coefficient, 212 lang po lalagay. For oxygen, 205, we know that, times 6. Okay, then plug in, add natin yung product, add yung reactant, and then subtract natin sa product, yung reactant. Then 212 plus 6, ayan, i-reconfirm natin kung tama ang sagot. Pindutin ulit ang calculator. So you have here 212 plus, may bagang manabang seat. Sorry. 6. 213.6. Ayan, nako.
Sir,
Tagaan
sir,
lang
205
natin.
po ata.
Sorry? Okay. So for the product, yun na ko. For the product, we have oxygen and glucose. You have here 212 plus 6 times 212. Tama? Glucose ito, and this is the oxygen. And then for the reactant side, okay. I think siguro na-confuse ka na akong. For the reactant side, you have here 6 times 213.6 for carbon dioxide. Pakicheck po kung ano po yung value sa table ninyo. I think 213.6 yan. Tama ba, guys? You can send a hard reaction to confirm kung tama. For carbon
Sir,
dioxide,
mali po yata yung nasulat niya sa calci, sir. Yung 205, 20 lang po yata nasulat.
Okay, okay. Thank you so much. Yun pala ang sinasabi na. Thank you, Ading. Ayun na, naglag na. Oops, wait tayo ng 10 seconds. Sumobra siya. Napagod na rin yung calculator. Give up na siya. Ne, apa yun? Maulaw. My God, okay. Ulitin natin. Naulaw ang calculator. 212 plus 2. Ayan, mainit ng panahon. Sagaan lang natin, mga ading. Minus 6. Sorry, 6 times 213.6. Pareho ba ang na-compute? Kindly send your answer on the chat box. I-reconfirm po natin kung tama ang ating sagot sa unang solution. Nag-syntax error, may napindot ako. Oops. Ayun. So you have negative 259. Let's see. Pareho po ba na-compute nyo? Alright, all good. So the unit there is joules per Kelvin only. Kindly correct that. Now, last example sa pag-compute ng entropy, tapos punta na tayo sa Gibbs free energy. Okay, parang po matapos na tayo. Medyo mahaba-haba na yung na-consume natin sa review. Last example, carbon, okay, for, I think ito ay yung part ng exercise 2 wherein you're asked to compute for the values. Ito pong ating solution for that. Exercise 2, activity 3. We are given the equation for number 1, carbon monoxide. Yeah, carbon monoxide is equal to hydrogen and it yields to ethyl alcohol. Ang carbon monoxide ay 198, ang hydrogen ay 131 or 130.6 siya or 131, it will do, multiplied to 2 moles. For ethyl alcohol, 126.8, 1 mole lang siya. Then we are asked to find the delta S. Now, we're ready to compute the value. Re-enter po natin. Kunin ulit ang calculator, mahiwagang calculator. Yan. Then, 198 plus 2 multiplied to 131. Ayan. And we got this value. Same po ba tayo nang na-compute? I-reconfirm mga admin. Enter ang value, 126.8. Yan, then send your answer on our chat box. Are you still there? Ako din, ako din gutom na rin. Ano na lang tubig, may tatawid natin itong review na to. Positive ang value na compute nyo. Okay, paki-indicate kung positive or negative ha. Kasi kung negative siya, ibig sabihin nun ay nag-decrease ang entropy. Parang nag-proceed siya sa more ordered, mas maayos na state. Pero kapag positive yung value ng delta S, ibig sabihin nun, mas gumulo. Mas dumami yung degree ng randomness ng particles. Okay? So in here, etong equation na to, pinapakita na to na mas naging ordered siya. From there, we can predict na yung equation, we can predict na since mas konti ang number of moles of product done on the reactant side, we can tell that the change in entropy is negative. We can tell that. We can tell that the entropy change is negative. Okay? You can take a screenshot of the solution, tapos kayo na bahala dyan. Tapos punta na po tayo sa enthalpy and Gibbs free. Yan, pwede niyo pong mag-take ng screenshot dito. Intindihan lang ang sulat ko. Oops. All right. I hope you did. Now let's move on to day number 16. Last na. Last na talaga. Ay, nako. Nakukomutan. Okay, sige, pahinga muna. Inom muna ng tubig. Medyo mainit ang panahon para kung hindi po tayo ma-dehydrate. Maybe our mayors could take photo during the discussion, tapos isend na lang sa ating GC, yung mga screenshots ninyo, you can share that also sa mga classmates na hindi naka-attend in case hindi nila ma-access yung video later on. Kasi may mga student talaga na mahirap ang signal sa kanila. So, they can only learn through screenshots. Okay? Paki-share na lang ating extend ang help. Oops, balikan ko po yung PowerPoint ni Sir Kenny. Ayan. I think pareho lang naman ang competition doon. Okay na tayo sa competition ng entropy. Alright, tandaan lang natin sa competition ng entropy, wag po natin pahirapan ang sarili natin. Ito lang yung formula, mag-isa lang naman. Product minus reactant. Okay? Are we all good? Can I receive a heart reaction kung okay na lahat for day number 15? Heart. Last na. 11:34. Time check. Diyos ko. Marami-rami ito. Pero last na ito. Saglit na ito kasi mag-subtract na lang. One example lang yung bibigay ko. Then, open ko later on yung sa PowerPoint ni Sir Kenny. Now, can we now proceed to Gibbs free energy? Can you still see my screen? Please respond. You can open
Yes, sir.
You can open tuloy your microphone. Okay, sige. Proceed na tayo dito. Now, punta tayo sa Gibbs free energy. Ang free energy is associated with a chemical reaction that can be used to do work. It can be calculated for a reaction, and it would tell us kung ang reaction ba ay natural na mangyayari or kailangan pa ng driving force or initiation para mangyari yung process. Okay, yun yung Gibbs free energy, yung function niya. And ang formula natin doon, pag kukunin natin yung change in free energy, we can use this formula, yung first one, pag yan lang ang given, yung product and reactant. Parang entropy din. Pero kung ang given ay yung enthalpy, tapos yung temperature at yung delta S, ito po yung formula natin. Delta G is equal to delta H minus T S. Delta S. Alright? Tandaan po natin na ang value na nakikita nyo sa inyong activity sheet ay measured under the condition 25 degrees Celsius or kinonvert siya into 298 Kelvin. Yun yung standard. Yung standard value na nakita nyo sa table ninyo, na-measure yan, na-compute yan gamit ang temperature na 298 Kelvin or 25 degrees Celsius. Now, we have the following situations in here in predicting whether a reaction is non-spontaneous or spontaneous. Okay. Pero bago yan, bago i-present yan, punta tayo sa example ng spontaneous processes and non-spontaneous. Okay, we have the following examples for spontaneous. Maki-ayon ka sana. Examples of spontaneous processes, one is dissolution of NaCl in water. Pag nag-dissolve tayo ng asin sa tubig without ionization, it will dissolve naturally. For number 2, yun yung spontaneous process. Number 2 is evaporation of water in open vessel. Even kahit sa ang tubig na nakikita nyo, tubig dyan sa kalsada, tubig dyan sa drum na naka-araw, it will happen. The evaporation will happen naturally. For number 3, heat transfer from hot body to cold body. Ayan yung principle natin kanina sa second law of thermodynamics. Alright? Number 4, flow of water down a hill sa waterfalls. Since it was acted upon by the gravitational force, it will flow downward. Okay, natural, yun na nangyayari. Number 5, an isotope undergoes radioactive disintegration. Like yung uranium, since it has a large nucleus, since malaki yung nucleus niya, it has a natural tendency to disintegrate. Okay, kaya tinatawag silang radioactive kasi they have this property to integrate dahil sobrang laki ng nucleus niya. Marami yung neutron. Okay? Those are some examples ng spontaneous. Other examples naman for non-spontaneous naman, yung hindi natural na nangyayari at kailangan niya ng initiation, ng driving force para mangyari yung process. Number 1 is diffusion of gas from low pressure to high pressure. Okay. Kapag umutot ka, anong direction umutot mo? Ang direction niya is from higher pressure to low pressure. Bakit nga ba tayo nagkakaroon ng hangin? Ang hangin ay naproproduce siya because of the differences in pressure, atmospheric pressure. Kung mataas ang atmospheric pressure dito sa amin, dito sa mga taron, tapos mababa ang laki naman ng area na tinutupik ko. Say, bawat barangay, kung mas mataas ang pressure dito sa barangay na dito, sa kabila ay mababa, there's a tendency na mag-flow yung gases towards the lower pressure area, then magpuproduce siya ng hangin. Okay, sabihin nila minsan, saan nanggaling ang hangin? Sabihin ng iba, kasi nag-revolve or nagro-rotate ang Earth. Pwede ba yun? Or kasi, it's because naglalabas ng oxygen ang mga halaman, kaya may hangin. Pwede ba yun? Okay, ang reason kung bakit meron tayong hangin or breeze, it's because of the differences in pressure. Higher pressure ang movement to lower pressure. Never did from low to higher. Kung mangyayari man yung process na to, kailangan ng driving force. Number 2, flow of water up a hill, pabaliktad, against the gravity, non-spontaneous. Number 3, flow of heat from cold body to hot body, pabaliktad, kailangan ng driving force. Sample, refrigerator, pabaliktad. Number 4, soft-boiled egg becomes raw, yung nalambong, Ilocano. So yung boiled egg becomes raw. That is non-spontaneous. So the key point lang in here, kung siya ba ay natural na mangyari, hindi is, isipin mo kung kailangan ba niyang initiation? If hindi, it's spontaneous. If it's not, that is non-spontaneous. Now, let's look at the spontaneity. How do we predict? Paano ba tayo mag-predict gamit yung delta S and delta H? I hope you can still follow, ha? Narinig pa po ako?
Yes, sir.
Alright, all good. Sige. Ito yung summary. So, mabilis na lang ito. Malapit na tayong matapos. Kakain na rin. Okay, spontaneity. of reaction, could we tell kung yung reaction ba ay spontaneous or non-spontaneous? Gamit lang si delta S at delta H. Okay. Pag mataas ang energy, heat energy, positive, at mababa si entropy, since ang formula natin ay delta G is equal to H minus S, delta S minus S. Siyempre, kung mababa si delta S, tapos mataas ito, it would give us a positive delta G. Tama? Positive yung value niyan. Kaya ang mangyayari, yung process ay non-spontaneous. Kapag sobrang taas ng energy, enthalpy, change, mababang entropy, non-spontaneous. It would give us probably a positive delta G. Kapag mababa naman ang energy, heat energy, compared sa entropy, si entropy ay mataas siya. Since etong entropy na to ay sinusubtract natin doon. Ang tendency doon, it would probably give us a negative value for delta G, hence it's spontaneous. Tandaan, pag sinabi po nating positive delta G, non-spontaneous. Pag negative, it's spontaneous. And if you want to, pwede kang bumalik doon sa present kong diagram kanina, balikan mo yung sa may catalyst, di ba may diagram doon. That would make sense. Okay, pag positive ang delta G, non-spontaneous. Pag negative, spontaneous. Paano kung parehong negative ang delta S and delta H? Ang titignan mo ngayon ay ito. Pag positive, si product ng temperature at delta S, at low temperature, spontaneous si delta G. At high temperature, non-spontaneous siya. Pero kapag both positive, titingin ka ulit dito. Okay. Pwede nyo i-save itong table na to para kahit nag-college kayo, alam na alam nyo explain ang Gibbs free energy. Diba? Pag tinanong kayo, what is Gibbs free energy? Ganyan, diba? Tapos pag alam mo, parang matutuwa yung mga taong nakakakilala sa'yo because you know to explain this. Okay? Now, pag low temperature, non-spontaneous, at high temperature, it's spontaneous. Okay, now, let's move on sa competition. I hope you can still follow. Before we proceed, I would like to check if you have understand the concept. Tell me if the following is spontaneous or non-spontaneous. Asan yung example, Mr. Kenny? Andito yun eh. Okay, sige. Sagutan natin itong PowerPoint, Mr. Kenny. So we have the following. Number 1, flow of water down a hill. Is that spontaneous or non-spontaneous? Okay, let's have a concept check on our chat box. Please, okay, enter. Spontaneous S or NS, ganun lang, para mabilis mag-time. Number 1, flow of water down a hill, S or NS. All right, very, very good. That was S. How about number 2, a roaring bonfire? S. Would it be S? It would happen naturally. Okay. Number 3, a lump of sugar dissolves in water. Would it happen naturally? S or NS? How about for number 4? Yung a lump of sugar dissolves, I think that was spontaneous. For number 4, freezing water using a freezer. It needs a driving force. It means NS. All right, very, very good. How about number 5? Purifying oxidized gold. Probably this is non-spontaneous. All right, all good? Now, let's proceed sa competition. We are given the following equation. We have ammonium nitrate yields to ammonium ion and nitrate ion. And we are given the following values. Same thing ang gagawin sa exam and quiz, ibibigay ng value. Now, the first step in computing for delta G, hanapin si enthalpy at hanapin si entropy. Kanina, na-discuss na si entropy. Now, enthalpy, ganun lang din, product minus reactant. Now, again, the first step in computing is identify the value. For reactant ammonium nitrate, ang value ng ating, sorry, lalamunan ko. Okay. Ang value ng ating delta H for ammonium nitrate ay negative 365.56. For ammonium, that was 132.51. Can you still see by screen? Kita pa po? Buhay pa tayo?
Yes, sir.
All right, all good. I'll just proceed. For nitrate, we have 205. Now, compute for delta H. Enter ang mga value natin for product and the reactant. Ang product natin ay 132, negative 132.5 plus negative 205. Then subtract the value for the reactant. Ayan. And then let us reconfirm again. Send your answers on the chat box. I-confirm po natin kung tama po yung solution. 132.5 yan. Hindi ko na-correct. Hindi ko nabura. Can you send your answers on the chat box? So you have here negative 132.5 plus negative 205. Then subtract the reactant. Okay, so kung mapapansin natin, ang formula ng enthalpy entropy ay pareho lang, product minus reactant. Okay. 28.06. Do we have the same answer? All right, all good. Very, very good, Kyle. So you have 28.06. And what's the unit for enthalpy change? Anong unit niya? Tandaan po natin, that was reported into kilojoules. Malaking number siya. Kilojoules po ang unit natin. How about for entropy? Okay. Nawala na yung iba pala, no? 73 participants lang na iwan. Siguro naubusan ng load. Kaya, okay, how about for the entropy? Ang entropy, ayan, ibigay ko na lang ito. Sa entropy naman, you have here 146.4 plus 113.4 yung product. Tingnan mo lang sa table. For the product side, okay, ang product po natin ay ito, nitrate at ammonium. So 146 and 113 ang i-add. Then subtract natin yung reactant ammonium nitrate. Okay. Then we got the value 108.72. Now, since we have computed the delta H and delta S, we are now ready to compute for delta G. So paano natin i-compute ang delta G? Delta G is equal to delta H minus T delta S. So, plug in natin yung mga values. For delta H, 28.06 kilojoules. Since it was in kilojoules, dapat yung entropy natin ay nasa kilojoules din. So, gagawin natin sa entropy, 107.72, mag-divide lang ng 1,000. Because in 1 kilojoule, there are 1,000 joules. Okay? So 108.72 multiplied to divided by 1,000 joules. And then, anong temperature na gagamitin natin? Since the values are calculated under 25 degrees Celsius, ang temperature natin ay 298.15 Kelvin kasi mag-add ka ng 273. When we are converting, kung gusto mo i-convert ang Celsius to Kelvin, mag-add ka lang ng 273.15. Okay? And that's it. Okay, reconfirm lang natin at tapos na tayo sa ating discussion. Okay. Buksan nyo lang, paki-confirm kung pareho tayo ng sagot. The answer is negative 4.35. Please confirm by sending your answers on the chat box. Happy lunch. Charot, hindi pa tapos. I-confirm muna natin. At yung module 16, open ko pa yung module 16 ni Sir Kenny, padaanan natin. Baka may na-miss out tayong concept. Okay, while waiting. Sorry, ano pong sagot natin? Nagpareho ba? Paano po pag wala sa table yung entropy value ng product? Tapos reactant. So, I think, yun nga, yun yung problem natin na yung naka-attach doon sa activity sheet po ninyo ay kumbaga mga fundamental lang na substances ang nilagay. But we have a table also for that na complete siya sa lahat ng substances. Pero doon sa quiz and exam po natin, ibibigay naman po yung mga values na. So, wala na tayong problema doon. Alright, Mark? Okay na, dear? Okay, have you confirmed the answer in here? Na-confirm ba? Okay, can you send a heart reaction if you're still there? You're most welcome, Mark. Send a heart reaction kung buhay na buhay pa. Lunchtime na. Okay, ano lang, daanan lang natin itong PowerPoint. Tingnan natin, double check po natin. Entropy. I think na-touch naman po lahat. Okay, nasama lahat. Delta G. Okay, I would like to reiterate this. For delta G, the reaction is spontaneous if delta G is negative. pag positive daw was non-spontaneous. Ayun lang ang key concept ng day number 16. Alright. Dito pala yung mga examples pa natin. So I think that's it. I hope you have understand the concepts. Before we end, mabilis ang concept check lang tayo. Mabilis ang concept check tayo. Again, if delta G is positive, what does it mean? Is it S or NS? Spontaneous or non-spontaneous? Can you send your answer on the chat box? If delta G is positive, is it S or non-spontaneous? NS, if positive. If it's negative, that is S. What if we have high entropy but low enthalpy? S or NS? Mataas yung entropy, mababa sa enthalpy. It would give us a negative value for delta G. All right, very, very good. Kaya spontaneous siya. All right. How about we have a high value for enthalpy but low entropy? Okay, that is spontaneous. Okay, pag tumataas si entropy, bumababa si delta G. Pag tumataas si enthalpy, tumataas si delta G. That's how enthalpy and entropy affects delta G. And that's it for our session. What questions do you have in mind before we end? Okay, if none, can kindly send a heart reaction kung wala na, yay, tapos na. Can you send a heart reaction kapag done na? I mean, wala na pong katanungan and we can just end the session. Sir Kenny, pwede po pa natin i-send yung mga PowerPoint sa mga bata?
Yes po, okay lang naman, sir.
Okay, sir, i-share ko rin po sa kanila in case they want to review again the PowerPoint and yung file na ginamit kanina. Sir, may question daw po dito. Ilang items daw po, sir, ang ating exam and quiz?
The usual, sir, 30 items yung quiz, 30 items in yung exam.
Okay. Alright, sir. Thank you so much po. Bali, ang seat work po natin at quiz ay magkasama na. Tama, sir, no?
Yes po. So, next week, instead of the usual quiz na good for 1 hour na Thursday lang, the link will be open from Monday to Friday ng 6 p.m.
So, mahaba pala yung time nila sa pagsasagot.
Yes.
Very, very nice.
So, hanggang doon lang, sir.
Sir, may nag-ano po ba? May nag-take po ba ng photo kaya, sir? Kasi humihingi pala si sir, si ma'am principal ng photo daw. Hindi po ako nakapag-take ng photo. I hope.
Ay, hindi rin ako kasi hindi ko nabasa.
May nakapag-take po ba ng photo sa mga bata?
Okay lang.
Can you share?
Kung hindi man tayo nakapag-take, i-replay ko na lang yung video and then I'll take screenshots na lang.
Okay, sir. Kayo na po bahala dun, sir.
Yes po.
Kayo na po mag-send kay ma'am principal. Oh.
Yes po. Sige po. I-close ko na yung recording.
Yes po, ma'am. Ay, sir.